Greetings and welcome, friends. Mr. Wada here, 4.2 Big Ideas Geometry, talking about reflections. It's amazing. I can't wait to watch this video later and reflect on how amazing it is. Here we go. Definition, core concept. A reflection is a transformation that uses a line like a mirror. Ooh, guys, wow. To reflect a figure. The mirror line is called the line of reflection. That makes sense. Let's see, a reflection in a line M maps every point P in the plane to a point P prime so that for each point, one of the following properties is true. Let's see. This is the one that's going to apply most of the time, and this is the one that's like, I guess makes sense, but is going to be less of the time. Let's see, it says if P is not on M, so here we go, there's P, it's not on M. Then M is the perpendicular bisector of PP prime. Yeah. So so the point P prime will be equidistant from line M, like so, and perpendicular to it. That makes sense? Good. And then also, if P is on M, then it maps to itself. True story. Yes. All right, so reflections, and that's also kind of what we noticed when we were dealing with reflections earlier. All right, so let's do an example. Looks like I need a grid. I think I gave you guys a grid, but I didn't give me a grid. Man, classic mistake, Mr. Waddy. For shame. All right, I'm going to have to steal a grid. So here we go. Start reading this problem. Oh, man. Guys, I don't have a grid. Where's my grid at? Man, my old dog, we used to be able to say, Stormy, Chewbacca, and then she'd all go, and it was pretty amazing. Yeah. I don't know. I just made that noise, and then I was thinking about my dog. But my dog's not with us anymore. Yeah. Don't worry, it was like a few years ago. It's not like it's a recent wound in my heart. Let's see. Her name was Stormy. She was also in my wedding. Yeah. So anyways, I'm just making graphs here, and sorry for the delay, friends. Internet friends, hopefully you're having a good time. You're hanging out. Oh man. But I guess this is faster than if I was just drawing a grid. That would have been sad. There we go. Bam, look at that. Grid. So, all right, you guys had your grids, right? I think I helped you out. I didn't help me out. So graph triangle abaca with vertices 1, 3, 5, 2, and 2, 1, and its image after the reflection described. Interesting. Interessante. Okay, so let's see. I'm going to run out of space if I'm not careful here. Right? Are you guys going to run out of space? Let's see. So I think my y-axis I'm going to throw about here, maybe over here. There's my y-axis. This one's all of those are in the first quadrant. So I'm going to make my graph mostly the first quadrant. So there's my x-axis. All right, so let's plot our original. I've got A is 1, 3. There is A like that. B is at 5, 2. So over 1, 2, 3, 4, 5, and up 2 like that. So there's A, there's B. Where's the C? Here we go. 2, 1, over 2, up 1. There is C. Now, notice I am going to mirror this, not over the x, not over the y, but over the line x equals 3, which I guess would have required you to be familiar with the algebraic concept that that is going to be a vertical line, which, if you want, you could watch one of my videos about graphing lines in standard form from my Algebra 1 videos. that playlist is also available on this channel. Hooray. Hooray. So if I'm plotting A prime is going to be perpendicular and equidistant from A. There's A prime. You guys agree? Looks like. If I'm plotting B prime is going to be perpendicular and equidistant, like so. There's B prime. All right, so I'm going perpendicular to my mirror line and equidistant from it. And C is right here. It's 1 unit away, perpendicular to the blue line. So 1 unit away, perpendicular to the blue line in the opposite direction will be C prime. And I guess I'll try to draw a sad triangle without using my ruler tool. It would look something like of the sort. And then look, it actually even like mirrored over itself, but that's cool. That's cool. Yeah, it's like some cool, I should use that as the logo for my Wadi Math. It's almost like some geometric W thing. You pretend hard enough. Let's do the same thing, except over the line y equals 1. All right, here we go, here we go. So here's, if this is my x-axis, we'll do roughly the same spot. Here's my y-axis. Let's plot our points. Abaca. A, once again, was 1, 3. So right 1, up 3. There's A. B was 5, 2, over 5, up 2. There's B. And C was over 2, up 1. There is C. There's my original. Excellent little sketch right there. I'm graphing it, I'm reflecting it over the line y equals 1, which is going to be a horizontal line with a y-intercept of uno. Right? Ooh, I almost, that's good enough. So there's my, mirror line right here. Gorgeous mirror line, if I ever saw one. So to map A to A prime, well, perpendicular to the line of reflection, 2 units away, mapped it over here like so. That's going to be my A prime. Mapping C to C prime. Uh-oh, guys, it's on the line. It's mapped to itself. It just stays there. Yeah, it's got the most boring life of all points. And B, mapped to itself, B is 1 unit away, and perpendicular in the opposite direction would be B prime. And like so. Now, guys, do you think these triangles are congruent to each other? Do you think their corresponding angles are congruent? Do you think their corresponding segments are congruent? Yeah, I would think so. So these are probably going to be what we'll call in a moment a rigid transformation. A rigid transformation. But before I get there, where's my... There we are. Oh, it's always hiding on me. Hiding like an Easter egg in a video game. Here we go. So here's example dose. Let me get some grid up there. Grid. Bam. Coordinate plane. Man. It's all right. We're just hanging out. That's weird. My grid got... That is the most bizarre thing I've never seen happen before. Control C. Control V. So here we go. We're going to do the same idea, except nope, it is not behaving for me. I'm sorry, friends. We're going to graph this. We're going to reflect it over the line y equals x, which is a huge idea. I don't know if you guys, I don't remember, do you do inverse functions in the world of Algebra 1? Maybe it's an Algebra 2 concept. But reflecting over the line y equals x is absolutely something that happens in the world of functions and inverses. Okay, so here we go. I've got my points. Let's see, we've got to figure out where should I put my grid, because I'd like to kind of zoom in on the interesting parts. I think I'll just put it right here. Man, I'm so bad at drawing these lines. How are you guys at drawing your lines here? Pretty good, pretty good. We're all practicing. I don't understand how artists do it. Man, I don't get it. So let's plot our originals. -1, 2 is point F. Golf is at over 1 up to. All right. There's golf. And I'm just okay. I'm reflecting a segment. I was all ready for a triangle, but I guess not. That's fine. And let's see my line of reflection in classic blue. Let's see. Did I make a mistake? No. No, we're good. All right. Let's see here. The line y equals x. I don't know if you guys knew this, but it has a y-intercept of 0, so it passes through the origin. And it has a slope of 1, so notice I went up 1 over 1, up 1 over 1, up 1 over 1. And I get a nice line at a 45-degree angle passing through the origin. And so now I can perpendicular bisector this. So let's see, this is square root of 2 over 2 units away from that line. You don't need to know that. But I think you can see that it would have mapped right there for G prime. And let's see, this one would have been 3 square roots of 2 over 2 units away, or 1.5 diagonal boxes away. So 1.5 diagonal boxes away over here would be F prime, and then that would be that. Kind of got like a cool little trapezoid thing going though. Trapezoid, and here are some properties. When you guys were working earlier during the warm-up, some of you were like talking about these properties, and I don't think you even knew it. Pretty good though. But here's some rules, like so. Core concept, coordinate rules for reflections. If AB is reflected in the x-axis, all right, so x-axis is a horizontal line. Notice that the thing that changes is the y-coordinate of the point is opposited. That makes sense. All right, you opposite the y-coordinate. Now it's going to be underneath the x-axis if it was above, and vice versa if it was below. Let's see if it's reflected in the y-axis. You do that by simply oppositing the x-coordinate. You could look through some of our previous examples and see if that had worked when we did that reflection, and you would in fact realize that is the case. If we reflect over the line y equals x, notice this symmetric concept. If y equals x, then I actually will switch x for y. Notice that switcheroo that happened there. And if I reflect over the line y equals negative x, which is at like a negative 45-degree angle, the slope -1, you switch them and negate them. Yeah. So switch them and opposite them. All right, that's almost like the contrapositive of the point, but that language makes no sense when applying it to this thing. But I don't know, it kind of feels contrapositive-ish. Do you agree? I don't know. You guys agree? No? Disagree? So let's do an example of this. Reflect in the line y equals negative x. Graph f of g from example 2 and its image. All right. Tell you what, watch this. I'm gonna done steal this. Oh no, you didn't. Watch this. Ready? Listen for it. Yoink. That's what you do when you steal something. I don't know if you guys knew that. That's the sound effect you're supposed to make when thieving. It's general rule. So let's see. So that was the original reflection. Let's mirror this over the line y equals negative x, and we'll test to see if this property works. If I could have just simply opposited and flipped those coordinates. So let's see. So I will map this onto I don't know, what's a good color? Orange, I guess. So f would have been mapped over to here for f prime. I should call that f prime. You're right. There's f. G would have been mapped over to, let's see, that's 1.5 diagonals. 1.5 diagonals is right there. So that's where the G prime would have been. Notice G prime, the orange G prime, has coordinates what? Looks like -2 and -1. And F prime has coordinates at, looks like -2 up 1. All right? And what were the coordinates of the original F and G. Yeah, -1, 2, and 1, 2. And notice to go from here to there, or vice versa, because by the way, 2 reflections will bring you back to your original location. Double reflection, don't know if you knew that. That I could have just flipped those points and changed their signs. Seems to work out. Flip the points, change the signs. Yeah, that makes sense. That just makes good sense. I think you'd agree. Let's see. So we talked about, let's see, here's reflection postulate. We still got time, friends. We got 4 minutes. Slow down. Slow your roll. It's going to be okay. Reflection postulate. A reflection is a rigid motion, right? And we had already hypothesized that. We done made a conjecture about that, and I think you guys agree. Don't worry, we're going to keep going. We're going to keep going. So reflection is a rigid motion. The shape remains the same size, has the same angles. Guys, don't pack up yet. We still got 3 minutes, friends. I can keep you 3 minutes late if you are worried about your 3 minutes, because I'm worried about my 3 minutes. Let's see. So here we go. The corresponding sides are still congruent. The corresponding angles are still congruent. This kind of makes sense. So corresponding parts are congruent. That's a big theme that'll come up later when we're proving triangles congruent. Good times. Let's see. Ready for an awesome composition? Look at this. Good times. All right, guys, ready for this? Are you ready for a 2-step dance move here? You got to do the scarn. Here you go. All right, yeah. So a glide reflection is a transformation involving a translation, which is when you slide it, followed by a reflection when you flip it. All right? So you guys will all be trying these dance moves later. So step 1, translate from P to P prime, and then reflect over a line. There's P double prime. All right, makes sense. Makes sense. Glide reflection. You guys like that? You guys like glide reflections? Let's see. Well, we'll do an example here. All right, that's like a generic, but let's perform a glide reflection like so. It says, so graph triangle ABC with the vertices. Tell you what, for sake of time, ready for this? It's going to be great. I'm super good at graphing. And bam, look at that. So first I draw this realistic head, and then I erase some of the more detailed features. And then bam, look at that. I'm done. So to map from A to A prime, I do a translation, subtracting 12 from the x coordinates. And then I reflect it over the x-axis, and I go bam, and just like so. All right, and then you would do that with all of the corresponding points. All right, have a good day, friends, and you as well, internet friends.